Welcome back to my YouTube channel. In this class, I am going to discuss about the second law of thermodynamics. This is a new chapter that I am going to start. And in my previous lectures, I have already discussed about the first law of thermodynamics, which is also known as the conservation of energy principle, and its application to processes involving closed and open systems. We have already discussed about the steady flow energy equation and an energy balance for unsteady flow processes. So everything relating to first law of thermodynamics has been discussed. Now it's time to start the second law of thermodynamics. Before starting, I must say one thing to all of you. Please do subscribe to this channel. Of course, like it and share it to your friends. Let's get started. So, second law of thermodynamics. Before starting second law of thermodynamics, we must know that no process in nature has been seen to be violating first law of thermodynamics or conservation of energy principle. Energy is neither created nor can it be destroyed. It is just converted from one form to another. It is just transformed from one form to another. This is what basically the first law of thermodynamics or conservation of energy principle states. So, no process in nature has ever been found to violate the first law of thermodynamics. But that does not necessarily mean that a process which satisfies first law of thermodynamics is bound to happen. There are certain processes which may be satisfying first law of thermodynamics, but those processes do not occur really in nature. So why? Despite satisfying first law of thermodynamics or conservation of energy principle, why do those processes not occur in nature? That's the basic question that we have to answer. We have to find out answers. So, first we must go through certain examples where those processes satisfy, even by satisfying first law of thermodynamics, don't really occur in nature. For example, you see, suppose a cup of hot coffee is there. Cup of hot coffee is there. Cup of hot coffee. You see, a cup of hot coffee placed in a cold room. So suppose the room air temperature is less than the temperature of the hot coffee. Eventually what happens, with the passage of time, the hot coffee gets cooler because the heat lost by the coffee is equal to heat gained by room air. We know that heat always flows from high temperature body to low temperature body. So hot coffee जो है वो lose करेगा some heat and by giving it to the room air. So the energy lost by hot coffee here is equal to energy gained by the cold air inside the room. That means it satisfies the first law of thermodynamics, and it also occurs in nature spontaneously, because we know that hot coffee after some time gets cooled down because the room air temperature of room air is less than the hot temperature of hot coffee, and the heat as a form of energy is transferred from hot coffee to the room air. And heat, the principle is, first law of thermodynamics says that the energy lost by one body is equal to energy gained by other body. So that conservation of energy principle holds good, and the process occurs in nature. But what about the reverse process? Suppose I'll say a cold coffee, suppose the same hot coffee, can a hot coffee, so I'll ask a question to you, can a hot coffee get hotter in a colder room? ये तो हॉट कॉफी कूल हो गया विद द पैसेज ऑफ टाइम, ये नेचुरल प्रोसेस है, इट ऑकर्स एंड इट सेटिस्फाइज फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, इट्स अ feasible process. But can a hot coffee get hotter in a colder room? Everybody knows that this doesn't actually happen in nature. A hot coffee तो hotter कैसे होगा? But had it occurred, it would not have violated फर्स्ट लॉ ऑफ थर्मोडायनामिक्स. ये तो प्रोसेस नहीं होता है, लेकिन अगर होता, ये फर्स्ट लॉ का वायोलेशन नहीं किया होता. जैसे कि had this process occurred, it would not have violated first law of thermodynamics as long as heat lost by cold air is equal to heat gained by hot coffee. ये हॉट कॉफ़ी अगर रूम एयर, कोल्ड एयर अगर कुछ हीट देता ये हॉट कॉफ़ी को, तो वो और भी हॉटर हो सकता था. ये अगर होता तो फर्स्ट लॉ ऑफ थर्मोडायनामिक्स तो वायोलेटेड नहीं होता, वो तो फर्स्ट लॉ ऑफ थर्मोडायनामिक्स वुड बी सेटिस्फाइड. इफ दिस कुड हैपन देन फर्स्ट लॉ ऑफ थर्मोडायनामिक्स वुड बी सेटिस्फाइड. But this doesn't actually happen. Even though this satisfies first law of thermodynamics, this process doesn't actually occur in nature. So this is an example that even despite satisfying first law of thermodynamics, a process cannot occur in nature. So second example को अगर हम जाएंगे, suppose we know that we are heating the room. In winter we need to heat a room because the temperature is very less, so we need a water heater, room heater. So that's why what we do is, suppose this is a resistor, and if we pass some current through it, it will generate heat, because this is a process in which the conversion of electrical energy to heat energy takes place. There is no problem in it. Here the first law of thermodynamics is satisfied, because the electrical energy is given into the system during a process, and that electrical energy will be converted into heat energy in steady state. So amount of electrical energy is equal to amount of heat dissipated from this resistor. There is no problem in that. But what about the reverse process? Can this process occur? You see, if we supply heat, can this produce any electric current? If we supply heat to this resistor, can this produce electricity? This actually doesn't occur in nature. But had it occurred, there would be no violation of first law of thermodynamics, because energy just gets converted from one form to another. Here heat energy is supplied and electrical energy would be produced. So there would be no violation of first law of thermodynamics. ये तो first law को violate नहीं कर रहा है, फिर भी this process doesn't occur. This reverse process doesn't occur. So another example may be, suppose here is a container containing some fluid, and this is a pedal wheel mechanism. ये pedal wheel जब certain mass is gets lowered, that means potential energy of this mass gets decreased. This results in stirring of this fluid, and with this some heat energy is produced, or the internal energy of the fluid gets increased. Internal energy of the fluid gets increased. Here also the first law of thermodynamics is satisfied, because you see the decrease in potential energy is converted into increase in internal energy. Internal energy के बढ़ने के कारण यहाँ temperature में increase होगा. So that means is temperature of this fluid or internal energy of this fluid will increase. Will the reverse process actually occur? If we supply heat to this, if we supply heat to this fluid, then क्या ये जो पेडल व्हील है ये रोटेट करेगा? ये तो नहीं होगा. ये प्रोसेस तो इट कैनॉट ऑकर, एंड दिस मास विल बी रेज्ड. कैन दिस प्रोसेस ऑकर? ऐसा तो नहीं होगा. सो रिवर्स प्रोसेस डू नॉट ऑकर इन नेचर। सो ए प्रोसेस जो है ये process occur only in one direction, process occur in only in one direction spontaneously। जैसे वाटरफॉल हाई प्रेशर से लो प्रेशर को होता है, इलेक्ट्रिक करंट हाई वोल्टेज से लो वोल्टेज तक जाता है, हीट फ्लो ऑकर्स फ्रॉम हाई टेम्परेचर टू लो टेम्परेचर। लेकिन रिवर्स प्रोसेस डज नॉट ऑकर इन नेचर स्पॉन्टानियसली। अगर ये रिवर्स प्रोसेस को होना है तो सराउंडिंग हैज़ टू डू सम वर्क फ्रॉम आउटसाइड। सो actually this is one of the greatest limitation of first law of thermodynamics, that it doesn't tell about the feasibility of the process। ये सारे जो तीनों प्रोसेस हम डिस्कस किए उनमें हर जो नेचुरल प्रोसेस है ये एक डायरेक्शन में होता है, लेकिन हर जो रिवर्स प्रोसेस है एक्चुअली they do not occur because they violate the second law of thermodynamics। we will come to know during the course that why do these processes not occur, only because they do not satisfy the second law of thermodynamics, and for that a property called entropy is very much responsible, and by discovering that property we will be in a position to find out which process is feasible or not by calculating the change in entropy of universe। we will study later on। सो जैसे कि फर्स्ट लॉ ऑफ थर्मोडायनामिक्स एनर्जी को एम्फसाइज करता है, ऐसे सेकेंड लॉ ऑफ थर्मोडायनामिक्स डिस्कवर्स अनदर प्रॉपर्टी ऑफ सिस्टम, दैट इज एंट्रोपी, and only with the calculation of entropy of universe we will be in a position to find out whether any process is feasible or not, and principle of increase of entropy will be discussed। with the use of that principle we will be in a position to know whether a natural process is feasible or not। So one of the greatest limitation of first law of thermodynamics is that it does not indicate the feasibility of process। एक process जो feasible है कि नहीं ये सिर्फ फर्स्ट लॉ को सेटिस्फाई करने से हम ये बोल नहीं सकते। a process has to satisfy both first law and second law, both first law and second law to occur। a process feasible होने के लिए both first law and second law को सेटिस्फाई करना पड़ेगा। जैसे कि हमारा जो ये तीनों जो रिवर्स प्रोसेसेस वी डिस्कस्ड, दे डू नॉट सेटिस्फाई सेकेंड लॉ। वी विल कम टू नो ड्यूरिंग द प्रोसेस only because they do not satisfy second law। of course they have satisfied the first law but they are not feasible। so second law का पहला important जो रोल है, it discusses about the feasibility of processes। second law can only decide which process is feasible or not। and the second most important thing that second law does is second law affixes a quality index to energy। so first law does not tell anything about the quality of energy, it only discusses about the quantity of energy, but second law gives a quality index to energy। so it segregates energy into two categories। one is high grade energy जिसमें all types of work be it mechanical work or electrical work, जो भी वर्क है। and another categories of energy is low grade energy। इसमें हीट आता है, हीट derived from any sources, मे बी फ्रॉम न्यूक्लियर फ्यूजन हो और फॉसिल फ्यूल्स हो, जहाँ भी हीट आता है वो हीट कम्स अंडर लो ग्रेड एनर्जी, एंड ऑल अदर फॉर्म्स ऑल टाइप्स ऑफ वर्क कम अंडर हाई ग्रेड एनर्जी। क्यों ऐसे बोलते हैं? क्योंकि कंप्लीट कन्वर्जन the complete and continuous conversion of heat into work is not possible. You know, that's why heat is called low grade energy. Heat cannot be converted completely and directly into work, but work can be converted easily and completely to heat. But for heat to be converted into work completely needs certain devices like heat engines and other devices also. So it needs some engines. Heat to be converted completely to work, we need some devices like heat engines. So that's why heat comes under low grade energy and वर्क कम अंडर हाई ग्रेड एनर्जी, क्योंकि हम मैकेनिकल वर्क को इलेक्ट्रिकल वर्क में कन्वर्ट कर सकते हैं, इलेक्ट्रिकल वर्क को मैकेनिकल वर्क में कन्वर्ट कर सकते हैं, लेकिन हीट को कम्प्लीटली हम वर्क से कन्वर्ट नहीं कर सकते हैं. जैसे कि एग्जांपल अगर लेंगे, सपोज ये एक सिस्टम है, ये कंटेनर है विच कंटेन्स सम वाटर. यहाँ हम कुछ सॉफ्ट वर्क अगर देंगे इस कंटेनर को, so its internal energy will increase. If you rotate the shaft, that means some mechanical work, if it is imparted to this container, its internal energy will increase and it will be dissipated as heat. Suppose its internal energy will increase and heat will be dissipated because temperature will be more than that of surrounding, so heat will be dissipated if the wall is diathermic, you see. So but what about the reverse process? But the reverse process will not happen. You see, suppose if we supply heat here, will the shaft rotate? Even after supplying heat to this container containing some fluid, will the shaft rotate? And in fact, that will not happen. So no work will be produced here. Even though if you supply heat, no work will be produced. So conversion of heat into work is not that easy and direct. So for that we need a certain device which is called heat engine. So जो second law है, ये first it tells about the direction of the process. It tells about the direction in which a process can occur spontaneously, or a process is feasible in which direction, or it tells about the feasibility of the process. Secondly, it affixes a quality index to energy and segregates the energy into two types, that is high grade energy and low grade energy. How do you classify the high grade energy and low grade energy? Because low grade energy is not completely and easily convertible to high grade energy. That's why they are called low grade energy. So जैसे कि हम we will study later on. So quality wise कैसे एनर्जी डिफरेंस होता है, we'll come to study later on. Suppose यहाँ एक सोर्स है, जो व्हाट इज सोर्स विल स्टडी लेटर ऑन. ये सोर्स से अगर इसका टेम्परेचर 1000 केल्विन है, यहाँ अगर कुछ 500 किलो जूल एनर्जी आ रहा है, और वहाँ एक रिजर्वर जो है 500 केल्विन, वहाँ से भी 500 किलो जूल एनर्जी आ रहा है. ये क्वांटिटी वाइज सेम है, 500 किलो जूल और 500 किलो जूल. लेकिन इसका क्वालिटी ज़्यादा अच्छा रहेगा क्योंकि ये 1000 Kelvin से आ रहा है. We'll study later on while studying about the available energy, exergy, etc. So these are the important features of second law of thermodynamics. First is it tells about the feasibility of processes. It can tell whether the process is feasible or not, and we conclude that a process can only occur if and only if it satisfies both first law and second law. Only by satisfying first law alone a process cannot occur, because it has to satisfy both first law and second law. Second thing what it does is it segregates energy into two types, low grade and high grade energy, and it affirms the principle that heat is a low grade energy and the complete and continuous conversion of heat into work is not that easy, not that direct, and for which we need certain kind of devices. And there are many valid statements of second law of thermodynamics, but we will study only two out of them. That is, one is Kelvin Planck statement and another is Clausius statement of second law of thermodynamics. So thanks for watching.